Okay, one final thing I would like to cover before we move on and do some Unity-specific programming is touch upon the third part of the OOP Holy Trinity of defining principles. So in object-oriented programming, there are said to be three main principles or pillars that make a language object-oriented. We've already looked at two of these three pillars of OOP. We've looked at encapsulation, so all of those containment structures, classes, object containment / composition, and so on. Inheritance, which is pretty self-explanatory. And the one we have yet to cover is called polymorphism, which sounds like an incredibly scary term, but isn't too difficult to understand. Polymorphism simply refers to aspects in code that can take many forms, hence poly and morphic. So we'll look at that in this video, but before we move forward, I want to actually make some changes to where we left off and go back to originally we were inputting, what was it, a night? So we'll change that reference back to taking in a night object for the deflect method. We'll comment out the reference to the string because we're no longer passing in just the string, and we'll comment back in the previous code. I'll put a little comment here. For future reference. And back in our RPG controller, we'll want to also put back the references to the night object. Right? So here, and we also made reference here too. All right. Building it to make sure everything's kosher. Yep. We're all good. Now, we'll make a new method to illustrate polymorphism. Get these out of the way. Called polymorphism. We'll write in something for that shortly and call that here. Now in the previous video we saw how we made this method that takes in a knight that can deflect his weapon and so on. But what if you want to use this very same method, the deflect method here, what if you want to use it performing the same basic process, but instead allowing you to input a wizard or any other class that you may be using in your game? You'll have a lot of duplicate code if you make different methods, each just taking in a different object type as an input parameter. So polymorphism comes to the rescue in exactly this case. Let's start by reworking our inheritance tree so that our classes now inherit from a common base class instead. So let's make a common base class called Combatant. And we'll give that base class a weapon. And now what we'll do, since that will be inherited now, we can get rid of these weapon fields for each deriving class, inheriting class, in other words. So we'll have wizard inherit from combatant, and knight also inheriting from combatant. And why not, let's also make a elf class, a new class. We can make as many as we want. I'm going to stop at 3. All right, and actually just to make it a little bit more compact, we don't have any implementation details for these classes, so just have empty parentheses all on one line. Sorry, not parentheses, I mean the squiggly brackets, containment brackets. And now, with that inheritance structure in effect, let's change the deflect method to take in any kind of combatant, giving us that polymorphism that we've been talking about. combatant. And we're also going to want to change, it was referencing knight, now we know it's just going to be any kind of combatant. And here as well. Now, since a wizard, knight, or elf are all equally combatants, remember the way you think of inheritance, an elf is a combatant, a knight is a combatant, and a wizard is a combatant. You can input any one you want to get the same functionality without requiring any extra code. So let's just pull some of the code we already wrote for simplicity's sake. Here, what are we going to need? We'll need that. Well, why not? Let's just run that and see if it outputs the way we were hoping with polymorphism now in play. There we go, broken sword. So it correctly took in that knight object that's holding the sword. Instead of just a knight being input, now we allow it to input a combatant. Right? So to prove that this is working the way we're saying it is, let's make now an elf, for example. So let's just do it here. And give that elf a weapon type. Say arrow. Let's just go back to simply outputting a simple message. And now if it works all correctly, we should expect it to show what? You deflected the elf's arrow and degraded your weapon to 70. Right? Let's do it a slightly different way. Let's store our object, either a wizard, knight, or elf, into a combatant object. So let's do this. This also has harkens back a bit to our look at reference types. So we don't need to make a new combatant. We simply assign to this combatant, say, elf. And run it. There you go. It still has the same message. We input a combatant that we know is specifically of type elf, and as the base type is of type combatant. So that's why that works. So polymorphism lets you therefore specify the variable type as the broader base type, which then allows you to use the same variable. So in this case, a combatant, right? Even if we reference knight, it'll still work. Just to prove it to you. You deflected the knight's sword and degrade your weapon to 70. See, there you go. It allows you to use the same variable to reference objects of different types, but nonetheless share the common base type, such as in this case here. This works quite easily as long as there isn't anything elf or knight specific that you want to reference with this variable, the combatant variable right here. See, it just references the combatant's weapon, which is common to all combatants. We don't have any specific code specific to wizards, knights, and elves in our wizard, knight, and elf classes right now. But if we did, you wouldn't be able to reference it because we're treating it just as its base type, as a combatant. And we know that that allows it to have a weapon, and so far nothing else that's common to each type. Now let's take this even a step further. Is there even a broader base type that combatant inherits from? Well, it doesn't appear to be, right? We don't have the colon after combatant, right? Well, how's this for craziness? Since classes in C#, all are objects, they implicitly inherit from the broadest object type, which is just object. So you can even do this right now. You can make this of type object. And then in RPG classes here, let's just make a method. We're not really going to use it, but just for illustrative purposes, it takes in an object, right? Call it an object. Local to the method. And now, because it's an object, notice we don't really have a lot available to us as an object in this method. We'll come back to that in a second. For now, let's not really actually do anything. Let's just say do something that damages the object, right? Let's pretend it's got some code there that actually is useful and damages the object. And let's actually fix this. Let's go back to Combatant. And here, let's go object, an object equals knight. Or elf, whatever. Give equal opportunity to the elves out there. Right now that we have a method that takes in an object, I'm not going to write all the code here, but just to illustrate, let's take our wizard and part of his weapon now, he has a damage something method that takes in an object. Let's input that object. Now, this doesn't seem immediately useful, so let's say we have two objects that don't inherit from a common base type. So let's say you have something like this. Make another class that is not common to the combatant class, but is an object nonetheless. So let's say public class NPC, and another one, public class companion, that inherits from NPC. All right, so these are all objects, NPCs, companions, combatants, wizards, knights, elves, but they don't share a common inheritance other than the most basic common base type of type object. So now going back here, we can input into this method. Well, let's just get that out of the way. We already have an elf. Let's reference it there. Right, an elf at the base is an object, so that's perfectly legal. And we can also do something like this. You can imagine a scenario where this might actually be useful. Spirit familiar equals new companion. Right? And then again we'll call that damage something method. And this time we'll damage the spirit familiar, which works because we're just treating it as an object when it gets input into the damage something method. There's no real output here, so I'll just build it just to show you that there's nothing wrong with this code. So again, this is allowed to work, this method here, taking the object of either a combatant or an NPC, as long as it references something that's common to the base type here, because we're treating it just as an object. Now, that shows you the flexibility that you get with polymorphism, but bear in mind, as I said earlier, when you use this kind of polymorphism and treat an object just as its base type, in this case it's of type object, which is the broadest type around, and you can't do much with just objects, you won't be able to access the particular fields and methods that relate to the particular type. So unfortunately, if the companion class has a damage method, it won't be accessible when you treat it as just of type object. In these cases, you'll have to downcast to the more specific type, a companion or a combatant, or a more specific type than that, a wizard, knight, or an elf, for example, with a process called unboxing. Now, unboxing just checks to see if the object's specific type is of a certain type, say a companion, and casts to that type, so you can then treat it as that specific type with its own specific damage method. So you can achieve this casting with a series of if statements where it checks if it's a combatant, cast to combatant, and do this. If it's a wizard, cast to wizard, and do this. Otherwise, if it's an NPC or a companion, do that. Something like that would be how you would solve that problem. But it'd still have the benefit of having this generalized method that you only write once and take on, or it can take in as an input a variety of more broader base types, the broadest again being of type object. Now, this all might be a little bit confusing at this point. It probably should be. If you're not confused at this point, you've confronted these topics before, I'm quite sure. And it's a bit far afield from where we're at right now, I admit that. However, I just want to mention it so you don't scratch your head wondering about it too much when we first make use of it in our project. And I want to cover polymorphism before we start stepping away from pure C# and OOP. So I know we'll come back around to this topic in later lessons, so don't sweat it if you don't get it all right now. But thanks for following along, and I'll see you in the next lesson.